Any others? Five. All right, so let's do those two. So for 3, we're saying domain and range, but this is not a continuous graph, it's a discrete graph. There are random points everywhere. So when you list out your domain and your range, you're gonna list a bunch of numbers, least to greatest, and curly bracket. So domain furthest left to furthest right would be -3. -3, -1, 0, and 3. So least to greatest, left to right. And then your range, lowest to highest, would be -1, 0, 2, 3. So that would be your domain and range for this problem. Question on this one? Okay, 5 you may have seen before, you may have not seen before. Either way, that's okay. So this is talking about transformations for lines. And there are only 2 ways that lines can form. It's comparing the slope and y-intercept of the original, which is this one, to any others. The shifted up or down is talking about your y-intercept. So if we compare from 0 to 2, it went up 2. Or B is talking about the slopes, comparing 1 to -1/2. This is less than 1, so this would be less. Questions on 5? Does anyone need another copy of the notes from math class? Hey, do you have these notes? Noah, do you have these notes? Right, so we went through the first 3 examples on this page. On the back of this, we're gonna go through any of 4 through 6 that you want to see. So of those 3, are there any we want to see, go over, have questions about? Five, and then algebraically in the graph or in the table. In the graph, okay. So let's do 5 on the graph. So if you don't have your calculator, go ahead and go grab that. Well, there were 2 in the same pocket and maybe the one below. If not, just grab a different one. Go ahead and reset your calculator before you do anything else. Second plus 712. And then we're gonna put number 5 in your white equals. Once you have number 5 in your white equals, go ahead and hit graph. If we're looking for the point in the middle, it looks like this point would be our point in the middle on our y-axis. So that's at 1, 2, 4, 5, 6, 7, 8, 9, 0, 9. So we would put that point in the middle. And really from the graph, we can find our solutions and then just graph it afterwards. How many solutions do we have here? Whatever you just said. I was how many? 2, yes. Did you go through the x-axis? So then what are they? -3, 0, and what's the other one? +3, 0. So we would write those as either ordered pairs or as your solution set. That says ±3. Or you can write them as 2 separate things, -3, then +3. Right, we are gonna finish graphing this just for good practice of graphing. So on our x's, we would go backwards and forwards. And then we would have to figure out what our y values are, and we can do that from the graph. So if you can match it up and count it, then you can do that. I'm gonna do it using second trace. And finding our value when x is 1, 2, and 3. So put in 1 and hit enter, and it would tell me what that y value is, 8. I don't know if I can erase this. I was like, not gonna erase them. Well, that's- Let's see, I think this one. There we go. No, it doesn't work. Yeah. Yeah, just okay. I don't know. I think because it's already there. Okay. It does say 8, you just can't see it over there. So the eighth would repeat for -1 and 1. We could do the same thing for 2 and then 3. Second trace your value. And then when x is 2, so 5. And that would be for -2 and +2. And then the same thing. Second trace value when x is 3. And that would be 0. So once you have all of your table filled out, you can go ahead and graph those. No, this one's the other one. Yeah. Any others, 4 or 6 we want to see, go over, have questions about? If not, go to the next page. So this is the page that'll really help you with the Khan Academy that is due on Friday. So with this, we first have to find the solutions. So, and I know it's really small and blurry, try to count the best of your ability on us, or you can look at mine. What would your 2 solutions on number 1 be? Zero. I'm just gonna write it as x equals 2 for now. But if we were writing it as an ordered pair, yes, it would be 2 zeros. What's the other one? At -2, is that a solution? It is negative, it's not 2. So I think it's 1, 2, 3, -4. So when we find our solutions, they are exactly what they say. But when we write them as factor form, in factor form, and we always write the opposite. So instead of -4, it would be x plus 4. Instead of +2, it would be x minus. So then you could do a couple different things with this. One, if you wanted to see what the actual equation is, you could multiply these out. So we'll do that really quickly. So this would give us x squared minus 2x plus 4x minus 8. And then if you combine your like terms, we have y equals x squared plus 2x minus 8. So if we wanted to check did we find the right solutions? We could graph this and Desmos in the calculator and see, do those match, and they should. And then when we get back from lunch, I'll talk about why we do this. Okay, so let's finish this. On the side somewhere. Write these two things. X plus 4 equals 0 and x minus 2 equals 0. Just somewhere off to the side. So the reason we write them backwards is if we were to solve this, get x by itself, we would get our original zeros. And that's the goal. So it's put in factor form opposite, so that way, when it's solved, you get the actual zero. What questions do we have about that before we try the next one? So for the next 3 problems, we're really just gonna focus on finding the zeros and putting it in factor form. You can do this part if you want and do this part if you want, but it's not necessary. So for number 2, the zeros are really close together. What are those two? Seven and 8. So then how would we write both of these in factor form if it has to be the opposite? And think about how we wrote number 1. So not plus in this case would be opposite, so minus. Whether you put the 7 first or the 8 first doesn't matter. If you were to set both of these equal to 0 separately and solve them, you would get these two. And that's our goal. Questions on 2? What are the zeros for 3? Where does it cross the x-axis? -3 and -8. So then how would we write those two in factor form? X plus 3 and X plus 3. Again, doesn't matter which one we wrote first. Number 4, what are the zeros there? -1. And I can get it 5. The -1 and +5, how would we write those as factored form? in factor form. Think about how we wrote the other ones. What would those be? Factor form. Are they gonna have the same symbols or opposite? Both ones are opposite, yes. So I'm going to show you a couple examples of what you're going to see on your Khan Academy that is like this, but also somewhat different. So find some blank space on your notes somewhere or grab some more paper so you can write this down so that you have it for later when you try it. So we'll do this one first. For each set of things outside, things inside, we're going to set them equal to 0 and solve. So you would have 3 sets of things set equal to 0. Now, some of them, if they look like the x minus 2, we were just doing that, so you would know that's the opposite. You could still solve it, but you should know that that's the opposite. If it just has x and is not adding or subtracting, that's just going to be 0. But for the last one that has a coefficient in front of x and a constant, you'll have to actually solve that and figure out what that is. So this is where it's different. These two are where it's different. So then we need to plot those 3 zeros on this graph. So we know it would be 0. Over here.
Let's see, I might also have to do this. Oh. Okay, I don't know why that point is there, but
Let's see if it'll still mark it right without that being there. Okay, so we know 1 is at 0, 1 is at 2, and 1 is at 7/2. So if you're not sure what that is, you can put it in your calculator. But that should be 3.5.
You should be looking what's coming from the bottom. Yeah, like that.
Okay. So find the zeros, graph them. Some of them you don't have to graph or they're already graphed and you just have to figure out where they are or what they are. To be able to find your zeros, recognize how to solve them, what they look like. This is on the factor form one. The other one, you'll be given 2 sets of factors. And you'll either need to solve both or at least solve one if you can recognize what the other one's going to be. So like this one, I know it's going to be the opposite, 3. The other one I'd have to solve, set it equal to 0. And figure out what that fraction would be. So then lesser would just be which one is smaller. That could be negative. It could just be which one is smaller. So the negative 3/4 would be our lesser.
and then the positive 3 would be our greater. Right, so as long as you know how the zeros in factor form look and how to solve them, then you should be fine with it. But while you're doing either of those, if you need our help, let us know. Okay, you're not gonna practice just yet, but you will have time to practice in a moment. Do we have any questions on this? So we are gonna start the last lesson for quadratics and then finish it next class. Did I miss anybody? All right, so the last lesson is on a different way of solving, so recap all of our things. The first lesson was on how to solve using square roots, or the square root method. Second lesson was on graphing quadratics. Third was on finding the solutions. And then the last one is another way to solve. So there are multiple ways to solve quadratics. We're not talking about all of them. You'll learn both, if not all, in algebra 2, those of you going on. One of those methods is usually solving by factoring. So we did factoring last unit, but we're not solving by factoring exactly. This would be if you couldn't factor, what you would do instead. So we're gonna use this quadratic formula. Those of you going on to algebra 2, you'll use this a lot. They'll have you memorize it, so it would be in good habit to start to memorize it now. For every problem, we need to first make sure that this is equal to 0. It has 3 terms and it's equal to 0. And then label what your A, B, and C values are. That will help you when you go to put stuff into the format. If you need more space, feel free to grab extra paper. So once we have these labeled, we're going to go ahead and start putting everything into this formula. And it's going to start off x equals negative b. Our b is already negative, so I would just put both for now, the negative, negative. We'll simplify here in a moment. Plus or minus the square root of b squared, so the 6, minus 4, it's always going to be minus 4 no matter what, times your a value, which is 1, times your c value, which is 4. All over 2 times your a value, which is 1. So the negative b and the 2a part, that part should be similar from when we're finding our axis of symmetry. The part that's under the square root is different. Later you'll find out that this is called the discriminant. Once we have it set up, then we just start to simplify. Once we get the hang of this, we can start to skip steps, but for now we're just going to do each step. For each step, you should still have x equals. This becomes a positive 6 plus or minus. Negative 6 squared becomes what? Negative 6 times negative 6 is 36, positive 36. You can multiply these three numbers at the same time, so negative 4 times 1 times 4. What would that give us? And then 2 times 1 will give us. We've got a little smaller, but we have to keep going. 36 minus 16 is what? Don't guess. You can use your calculator.
Calculator's your best friend in this unit, guys.
The next part is you have to see, is that number a perfect square or not? So in your calculator, you can type in second x squared. Second mode to get out of whatever. Second x squared to get your square root. If I didn't hit second. There we go. Put 20 in, see do you get a whole number or not. So if we don't get a whole number, we can just leave it as is. But we have to separate it, the plus and the minus, and write them as two separate answers. In said notation, the lowest comes first, or the least comes first. So 6 minus the square root of 20 all over 2. And then 6 plus the square root of 20 all over 2. Now, in algebra 2, you'll simplify this a little bit further because you can simplify the radicals. We are not doing that. If we were to do anything with this, it would just be put all of this in and get it done. Which I'll do so you see what happens, but. So if I wanted to find the decimal, I would type in exactly what I had, 6 minus the square root of 20 all over 2. Write down 2 to 3 decimals of that. And then do the same thing with the positive version. So your solution set would be 0.763 and 5.236. I already forgot what it is. 6, 7, 7, 6, 3. Is that not backwards or right forward? Okay, that should be 4. So you could write it as either or. Questions on that? Yes. So we're gonna do a few more. Starting with example number 1. So here we have our 3 terms of equal to 0, so we can list our A, B, and C values. Then we can start to put it in the formula. X equals negative B, so 10, plus or minus the square root of B squared, so 10 squared. You can use parentheses and leave them out, either or doesn't matter. positive. Minus 4 times A, which is 1, times C, which is -2. All over 2A. Then we can start to simplify. Ten squared is what? 10 times 10.
Oh,
100. -4 times 1 times -2. +8. And then add 100 and add 8. Is 108 a perfect square? So we would just separate it and write it as two things. -10 minus the square root of 108 all over 2. And -10 plus the square root of 108 all over 2. Or you can find the decimals. Questions so far? For number 2, what do we notice that's different than the other two we did? Say that one more time. Right, it's not equal to 0, so we need it to be equal to 0, so we gotta get rid of this by moving it back to the other side. So we'll have to subtract that over first before we do anything else. And it still has to be in this format. So when we rewrite it, it'll be x squared minus 4x minus 11 equals 0. Then we could label our A, B, and C. Once we know what our A, B, and C are, we can start to put it in the format, in the formula. So x equals -b, but it's already negative. So at this point later, when you start to get used to it, if you want to just make that positive to begin with, you could do that. Plus or minus the square root of b squared. So if you wanted to put what b squared is right away, you could do that. I'm just still gonna put it as is. Minus 4 times a, which is 1, times c, all over 2a. And then we can start to simplify. So this would become a +4 plus or minus. Square root of, this would give us a +16. This would give us a +44. Yes. We multiply -4, 1, and -11, all the others. 16 plus 44 is what? 16. Is 60 a perfect square? We're gonna do the same thing. Separate it. 4 minus the square root of 60 all over 2. And 4 plus the square root of 60 all over 2. We are gonna do a problem where we actually do more, so you see what happens there too. Questions so far? this is really just use the formula, simplify. If you do all that fine, then you should be fine. Let's do 3. What do we have to do first? Okay, 0, so we would do what with this 20? We do have to make it 0, but we also have to get rid of the 20. What would we do? Or on that side? Say it again. So when we rewrite that, that's gonna go at the end. X squared minus 8x minus 20 equals 0. Then you can label your A, B, and C. And then start to put everything in your formula. So X equals negative B, but it's already negative. Plus or minus the square root, excuse me, of negative 8 squared minus 4